In this series of videos, we're going to be looking at the structural and functional differences between the different types of vessels that are used by the circulatory and lymphatic systems, starting with the difference between the two key types of blood vessels, arteries versus veins. The functional difference between the two is actually rather simple, and we're going to clarify a quick misunderstanding that many students often have about the difference between arteries and veins. The difference between arteries and veins is not whether they transport oxygenated blood versus deoxygenated blood. The difference is in terms of direction. An artery is simply any blood vessel that transports blood away from the heart. Now, this means that arteries are subjected to a much higher blood pressure than veins are because arteries are closer to the origin point of high blood pressure, that being the contraction of the ventricles and the pressure wave that pushes blood out of the heart into arteries, and therefore arteries need a much stronger while also having a much more flexible structure than veins are that actually allows the diameter and circumference of an artery to change. This is because the overwhelming majority of the tissue that an arterial wall is made of is actually muscle tissue. So all of this tissue in here is muscle, and this is what allows arteries to actually contract in order to get smaller, or in order to make the diameter narrower, or to relax in order to make their diameter wider, and both of these are done based on blood pressure. So what exactly does this mean? Well, remember that arteries are actually subject to, just like the heart is, sympathetic and parasympathetic responses, meaning that the medulla oblongata can actually directly manipulate the muscles within the walls of your arteries. So let's take a look at what happens during a sympathetic response, also called the fight or flight response. Now, in the event where you need to fight or flee for your life, chances are your blood flow needs to be sped up, because if your blood is transporting oxygen, the faster oxygen gets to your cells, specifically to your muscles, the more energy you can produce and the faster you can run in order to make your escape. Now, in this case, what the sympathetic response does is it triggers what we call vasoconstriction within the arteries. And the root of this word, vasoconstriction, is the verb to constrict, meaning that the muscles in the artery are going to contract in order to make the artery smaller, which increases the amount of blood pressure, or increases the pressure that the water in your blood exerts on the walls, and the overall result of this is that blood flow is going to move faster, therefore ensuring that the oxygen being transported by the blood gets to where it is going sooner and is used to produce energy in a much faster way in order for you to be able to fight or run for your life. However, just like all the symptoms of a sympathetic response, this is not sustainable in the long term, because the higher blood pressure, meaning the greater amount of force that the liquid part of your blood exerts on the walls, this can actually do structural damage to the walls of your arteries if the vessels remain constricted for the entirety of your life, and therefore we need the parasympathetic response in order to counteract this. So once the body recognizes, or specifically the brain recognizes, that we are running out of energy and can't sustain a fight or flight response for longer, the parasympathetic response kicks in and triggers the process of vasodilation within the blood vessels, or within the arteries rather. And the root of this word here is the word to dilate, which means to relax and get larger. The other way that the word dilate is often used is describing your eyes when your pupils get larger in order to let more light in. But in this case, the dilation occurs when the muscles in the arteries relax, therefore making the diameter of the arteries larger, therefore decreasing the amount of pressure that the water in your blood exerts on the walls of your arteries, therefore lowering blood pressure. Let me just fix that there. There we go. And because blood pressure is lower, there is less force that is pushing the liquid part of your blood to move in a specific direction, and therefore your blood flow is going to slow down as a consequence of this. Now, this flexibility, both in terms of their literal flexibility of being able to relax and contract, and their flexibility of function to speed up or slow down blood flow, is unique to arteries, because veins, as we can see, have a much different structure. Most notably, their muscle layer is much smaller. So the function of veins, the only functional difference of veins is that they transport blood back to the heart, meaning that their job is to collect all of the carbon dioxide that the cells in your body are going to produce in order to bring this back to the heart so that it can be then transported to the alveolar capillaries where they can be exported. Now, because of the fact that veins are much farther away from the heart, meaning they are farther away from the left ventricle that contributes most of the force required for increasing blood pressure, this means that the muscular layer does not need to be as thick as blood, as thick as it is in arteries, because veins in general are subjected to a much lower blood pressure and therefore don't really need to expand or contract in order to alleviate blood pressure or speed up the flow of blood. Probably the most key distinction structurally between arteries and veins is that veins actually have one-way valves that are similar in the function and also the structure to the semilunar valves that are found within the blood vessels that lead out of the heart. In other words, these one-way valves are meant to prevent blood from flowing backward in veins. Now, this is a unique problem in veins because as blood gets farther away from the heart and blood pressure decreases, there is less force that actually causes blood to move forward, meaning, especially during times when you are sedentary or not moving, it is physically possible for the blood in veins to drift backward, particularly in your legs, because blood actually needs to go up your legs working against gravity, and therefore these one-way valves that are found consistently within your veins exist to prevent blood flowing backward and pooling at the bottom of your body, ensuring that veins can get back to the heart. Now, this also represents another problem with veins in terms of blood flow. Because veins are much farther away from the beating part of the heart, from the left ventricle, they need a different propulsion system that actually propels the deoxygenated blood back to the heart, because they can't rely on the actual heartbeat in order to pump it all the way back to the heart, because at this point, most of the blood that is moving has lost a lot of its momentum as it rubs up against the walls of your blood vessels and as the friction slows down the flow of blood. Now, one of the other structural features of veins that makes them different than arteries is that veins are much closer to the surface of your skin. You should actually be able to see veins that appear as a greenish blue type of blood vessel here. This is structurally intended for them to be close to skeletal muscles, which are the muscles that are attached to your bones that allow voluntary movement. So the skeletal muscles in your legs are the muscles inside of your legs that you use for walking or any other activity involving the legs. And when the skeletal muscles contract whenever you move any part of your body, the skeletal muscles will compress the vein, and the one-way valves ensure that blood only flows in a single direction when the skeletal muscles are compressed, so that the one-way valve opens in the forward direction and closes in the reverse direction, so that the blood in your veins is pushed in only a single direction, ensuring that blood in veins eventually makes it back to the heart. And this combination of one-way valves as well as close proximity to the skeletal muscles ensures that blood flow is able to make it through veins back to the heart, despite being farther away from the heart and not being able to use the blood pressure from the heart in order to get back. Now that you've familiarized yourself with the structural and functional difference between arteries and veins, the next video is going to cover the broad organization of pulmonary versus systemic circulation, so that we can get a bigger picture about how blood flows back to the heart via veins and away from the heart using arteries.